Hello guys, welcome to learning microcontrollers. In this video I'm going to show you how we can interface two PIC16F877A microcontrollers with each other using UART protocol. UART stands for Universal Asynchronous Receiving and Transmitting. As the name suggests, we need two pins, that is RX and the TX pin, for this communication. So in this example I'm going to show you, I'm going to take one PIC, that is PIC 1, this one is the PIC 2. Then you know where the TX and RX pins are on the PIC16F877A microcontroller. These are our TX and RX pins. We only need these two pins in UART communications. Very simple. So pin number 25 is the TX pin of both PICs and pin number 26 is the RX pin. Now how to connect them with each other? TX of the first PIC will go to the RX of the second PIC, or RX of the first PIC will go to the TX of the second PIC. RX goes to TX and TX goes to RX. See, TX to RX and RX to TX. PIC 1 sends, PIC 2 receives, PIC 2 sends, PIC 1 receives. Okay, in this example I'm gonna take first button which is connected to pin number C0, second button connected to pin number C1 of the first PIC, third button connected to C2 of the first PIC, and fourth button connected to C3 of the first PIC. Then I'm gonna take four LEDs connected to the second pins B0, that is first LED connected to the pin B0, second LED connected to B1, third B2, fourth B3. So we have four buttons on PIC 1 and four LEDs on PIC 2. What is gonna happen is that when I press the C0 button, a 0 is sent to the PIC16F877A, that is the first PIC, and a char value 1 is sent through the TX, that is UART communication, to the second PIC. Then second PIC is programmed in a way that it turns on one LED. Now when I press the second button, a 2 is sent through the UART communication and it turns on two LEDs. And in the third button, a 3 is sent and it turns on its three LEDs. And finally a fourth button is pressed, that is connected to pin C3 of the first PIC. First PIC will send 4 and this 4 will turn on all four LEDs of the second PIC, like this. And now it will also be a two-way communication, like full duplex. Both can communicate with each other one at a time, or you can call it half duplex. So here I press the C0. Now the second PIC sends 1 to the first PIC and it turns on first LED. Now second button is pressed of the second PIC and two LEDs of the first PIC will turn on, because second PIC will send 2 to the first PIC, like this. Okay, when I press the third button of the second PIC, a char 3 is sent to the first PIC, and first PIC is programmed in a way that it will turn on all three LEDs. And when I press the C3, it will send letter 4, that is char 4, and all four LEDs of the first PIC will turn on. Now let's get to the Proteus demonstration. Okay, go to the Proteus, click on ISIS, go to Tools, select PIC16F877A. Okay, this is our one PIC. Since both PICs are same, we draw four LEDs, four buttons on the one PIC, then we copy paste it. We use a smart way. Take LEDs, take color, we need the color LEDs. Okay, these are color. Okay, green, blue will do. Okay, here we have our LEDs. LEDs are to be connected to pin 0 to, okay, here we go, 1, 2, 3, 4 LEDs. Connect them. Okay, we have 4 LEDs. We connect first LED to B0, second to B1, third to B2, and 4 to B3. Okay, then we ground all 4 LEDs. Okay, ground the other ends, take a ground. Okay, all 4 ends are grounded. Now we need to connect push buttons. First bring the push buttons, go to tools, push. Okay, write it complete button. Here we have our push buttons. We need to connect them to C0, C1, C2 and C3. We connect them here. That's our first button, second button, third button, and fourth button. Now we need, as usual, a pull-up register. I'm sending 0 through the button, or you can say a 0 will be programmed when I press the button. A 0 will be sent. So we have to program the 0 here. 2, 3, and 4 register for 4 buttons. One end of the register gets the power. You will power up the one end using the same source we used to power the PIC16F877A microcontroller. Okay, the other end goes to the button like this. Okay, here we go. Bring in the power, place it here, and connect it. Okay, the other end will be grounded. All 4 ends will be grounded of the buttons. This is a pull-up resistor connected in this formation. In this way, a 0 will be sent. Okay, ground all the 4 buttons from the. Now from here we take our output C0, C1, it goes here, C2, it goes here, and C3, it goes here. Okay, these are our basic connections. Now let's get to the programming. Turn on the MikroC for PIC, click on new project, next, write any name, learning micro UART interface. Okay, I'm using a 20 MHz crystal. PIC supports maximum is a 20. You can use any value below. Okay, here is our programming begins. First we declare our ports. TRISB is equal to 0 into 0, 0. We are using port B as output. Initial state must be equal to 0, like all the buttons must be 0. Okay, give a initialization delay, that is 100. Okay. Okay, last thing is we copy this. Now we bring in the second PIC. This is our second PIC, same configuration, only we need to now interconnect them using pin number TX, that is this pin. It will go to the RX of the second PIC. TX goes to RX, that is pin number 26. Okay, and then RX will go to the TX. Okay, take it to the TX. In this way 2 PICs are connected, only 2 wires are needed. Okay, here we go, TX to RX, check it, TX to RX, and here TX to RX. Okay, that's great. Okay, we have our 2 PICs. We had declared our variables, both are same. Port B is output, port C, 4 pins are input, TX and RX will be used by the UART module. So let's continue the programming. Okay, this is our output, then TRISB dot F0 is equal to 1, that is first button. Okay, no, port C dot F0 equal to 1. Okay, initial state must be 1, and 1 means input, 0 means output. This is our input, and we are only initializing 1 pin here, not the whole port. Give a delay because we have to use the UART module which is on the same port. Okay, this is our initialization delay. Copy pasted 3, 4. So second pin is 1, just change this pin number, rest is same, 3. So these are our 4 buttons, 1, 2, 3, 4. Now we need to initialize the UART module, UART 1 INIT. We give baud rate of 9600. That's great. Okay, give it an initialization delay, 500 will do fine. Okay, these variables or you can say ports are being initialized. Now the next thing is we start our forever loop. This is one time loop, right? While 1, and the loop begins here. Okay, these are closing bracket, opening bracket. First thing is we have to program the transmitting end when buttons are pressed. So we give it bracket transmission. Okay, here First thing is, when a button is pressed like this, when we press this button, a 1 must be sent as described in the presentation. So if port C dot F0 double equal to 0, then bracket starts, give a debounce delay ms 300 is fine. Okay, 300 delay. Then again write the above, copy paste it. This is debouncing delay in case the button is accidentally pressed. Ended with 2 brackets, first loop, second loop. Okay, now what happens is that go to library, here UART, this one, TX idle, we are transmitting something. UART write data, copy paste it. Now UART, what we want to send when button 0 is pressed, that is char 1. Char 1 will be sent, give a little bit of delay, that is 100 will do fine. Okay, when port C dot F0 is pressed, as said in the presentation, 1 will be sent. This is to check if the register is empty or not. Just write it as it is with every write command. With PIC16 series you need this, but PIC18 series you do not need to write this, or you can write this no matter. Now in case this don't happen, copy paste it. Now we need 4 buttons, 1 second button. Okay, it was if, this will be else if above is not done, then C0 F1 double equal to 0, F1 double, then 2 is sent if 2 is pressed. Then copy paste it. Third button. Okay, if C2 is pressed, 0 is received at the C2, then 3 is sent to the second PIC. Okay, then next is, if 3 is pressed, 1, 2, 3, then 4 is sent. All 4 LEDs will turn on. That is our transmission coding. If above conditions are not met, then give a dummy write command. That is, something will be written which will not affect the programming. Write any button which is not in use, like X is not being used here. So it is necessary, else it can damage your program. Okay, if none of these, then X. Now we write the receiving end. Now give it that we program the receiving, because one PIC will do both tasks, transmission and receiving. This is called one at a time half duplex communication, but two-way communication. It will send and it will receive. If both of these are doing at the same time, then it is full duplex. Okay, now what will happen is that go to library, select UART. We will first need to read. Okay, for that we need to initialize a variable called char. Right, use any variable like char read 1. It will store the value of char when a data is received. Now program it. Go this one. If data ready, if UART1 data ready, if RX register is empty, then receive data, and write it here. Okay, and we are using a variable read 1. Here it is. Okay, if a data is read, give a delay. Okay, something is read. Read 1 will read the signal. If now what read 1 has read? If read 1 double equal to, you can say 1 is read, then no need of debouncing delay here, because we will send an X. In case accidentally a letter is sent, it will be an X. Okay, if read 1 double equal to 1, then what happens is that port B.F0 first LED, as said in the presentation, first LED of the port B.F0 will turn on. Okay, here it turns on. Give a delay. Okay, give it a 100 ms delay. Now if something else is read, that is if else, if make it else. If above is not read and 2 is read, then 2 LEDs will turn on. That will be like this. F0 and F1 pin of port B both will turn on, send 1 to the LEDs, and if 3 is red, then 3 pins will turn on. Make it 3. Okay, F0, F1 and F2, all 3 pins turn on. And in case a 3 is red, copy paste it. 4 is red. In case 1 is red, 1 LED, that is B0 turns on, 2 F0 F1 turn, 3 F0 F1 F2 turn on, 4 F0 F1 F2, and F3 will also turn on. That will be like this. Port B dot F3 equals to 1. Now if nothing above the following is received, then make read1 receive something that is not needed. Okay, then read1 equals to 2. So no LED turn, or something that is not in use, you can name it C. Okay, C is not being used in the programming. That will be fine. Delay MS 50 will do fine. And now bring all these pins to the initial state in case nothing is received. That is all 3. This is the initial state, that is 0. We set it in the initial state that if nothing is received, then it goes back to this initial state. Okay, this is our programming of both the PICs. Both PICs will use the same programming. Okay, now we burn it in we go to the Proteus and run the simulation. Okay, here is our Proteus simulation that we made earlier. That is PIC1, that is PIC2. So click on it. We are using 20 MHz crystal. Select the code. That is the code we made. Here too, we are using 20 MHz crystal. Select the code. That is the one we just wrote. Okay, click on this simulation start button. Simulation begins. See, nothing is happening because we had given initial states. No LED turns on, no LED of the first PIC, no LED of the second PIC. Now we press the first button of the first PIC, that is this. I press it. Okay, it's pressed. It causes one LED of the second PIC to turn on as programmed. But when I press this button, second button, it causes 2 LEDs to turn on as programmed. So far so good. Now we press the third button, it causes 3 LEDs to turn on. Now I press the fourth button, it causes all 4 LEDs of the second PIC to turn on as programmed. Now we do the opposite. We press the first button of the second PIC. What happens? It causes 1 LED of the first PIC to turn on. Now we press the second button. It causes 2 LEDs of the first PIC to turn on. Now I press the third button. It causes 3 LEDs of the first PIC to turn on. Now I press the fourth button. It causes all 4 LEDs of the PIC to turn on. So now let's get to the hardware demonstration. Let me give you a hardware demonstration of the same code and simulation. Okay guys, here is our hardware. This is our first PIC and this is our second PIC. So there are our 4 buttons. I am using these 4. There are our LEDs of the second PIC. So I press the first button of the first PIC. See, or you can say this is the fourth button. We are going opposite here. All 4 LEDs turn on. As soon as I leave the button, it turns off. Okay, I press the third button. 3 turns on of the second PIC. Then I press the 2 turn on. Now I press the first button. Only 1 turns on. Now I press the buttons of the second PIC. All 4 turns on, fourth button. Then I press the button, second button, 3 turns on. You can see that. Then I press the second button. Okay, this button is a bit hard to press. Okay, let me press. Oh no, this is the fourth. This is the third. This is the fourth button. Only 1 turns on. And you press this button. Okay, 2 turn on. This is our second button. I press it, 2 turns on, and finally I press the first button. Okay, these buttons are a bit hard to press. Programming is working as in the Proteus simulation. Okay, you can see it is working as we wanted it to work. So guys, I hope you learned something from this video, and see you in the next video. Good luck until then.